Hi, so welcome. Enjoy the nice wintry weather. I'm Victor, and I'm going to give a slightly meaningless talk about nils, nil safety, how it has evolved in other languages, what it looks like in Go. This is not a proposal. I am not going to impact anything in your life. Any similarities with proposals are completely accidental, so don't worry about it. Having said that, let's jump straight in. So, as you know, nils are everywhere in Go, and a lot of types can be nil. In fact, very few can't be nil, as far as I'm aware. And we also take nils for granted. We use types that use nils in small scripts that clean up something, or even in fact in the standard library. And we use them without actually checking whether they are new or not. So we have no idea whether the values will lead to panics or not, as you can see here from the screenshots, especially pointer receivers. Like, we have decided as a whole that nobody cares to check pointer receivers, so we just carry on with our lives. But sometimes this leads to that. I'm sure everybody has seen this once or twice in their life. Basically, that's the no pointer exception equivalent in Go, for those that care. So we know that we can check these nillable types with an if statement, but for various reasons, we're not actually doing this. So what else can we do? Well, I did some digging into other languages, and it's certainly not exhaustive. And summarized my thoughts a while ago, and I think now is a good time as any to do a presentation on it. So there seems to be two camps when it comes to nil safety. And I will jump right into the first one, which is options-based. And it relies mostly on algebraic data type support in the language. So for those that don't know, options are usually a very specific subset of ADTs, which is called a sum type. They're a container that represents one of two options. Either there's data, something, 42, whatever, or there's nothing, literally. And you can only store one or the other. Or if you're in Java, you just YOLO the whole thing and just use a nullable class. And by wrapping the type that may or may not actually have data, you leave no chance to the user, which is all of you guys, to actually misuse the raw pointer and suddenly cause a panic. You can do that, but it's an explicit act. For example, if you just attempt to unwrap the option value or something. So with that said, here are a few examples of some of the languages that have options. And as you can see, a language may have special expressions for an if block that will extract the value if, for example, it actually contains something as opposed to nothing. And then you can just use that value inside the if block as if it was an actual thing. Or there may be pattern matching, where you can use either the data, or if there's nothing, you can do something completely different. You also are provided with options to provide a default value in case the option doesn't contain one, and you can check whether one exists and extract that. There are also ways to transform the value within if it's there, usually through some kind of a map function or a map method or so on, and get something that is completely different, only if there's an actual valid value. Now, when you consider everything, quite versatile, and in most cases, their usage is quite painless. Now, if your language of choice supports pattern matching, there are plenty of ways to easily extract the value, and that looks quite natural in the language. You also get special operators that you can use to work with those options. For example, the question dot, with which you can use, which you can extract values from a field if it is not null, or just return the zero value if it is. Or you can use the Elvis operator to supply a default value. And that's pretty much it. Unfortunately, Go supports neither some types nor has a strong affinity for adding new operators. I mean, we've all seen various proposals over the years for adding even support for existing operators for things like big integer and so on. But for one reason or another, they have always been rejected. Well, at least there's a proposal for some types which hasn't been rejected yet, but that's been hanging there for years now, and it doesn't seem likely that it will be approved anytime soon. We also don't have anything like Java streams, although now we do have iterators, and that's the reason why Java added supports for optionals in the first place. But at least with iterators, perhaps we can use them to specify, to wrap around values that are nil, though it doesn't seem likely. And finally, with the pointer receivers, it's not very, let's say, user-friendly to use optionals with them, because you have to check all the time and it just doesn't look okay. Even with such limitations, this approach is actually implementable in Go, because Go finally supports type parameters. That's why there are packages such as this one, which I found by quick Googling. And the results are okay-ish, let's say. Certainly somebody somewhere is using that in production. I have no idea who, but definitely. Right, so that was the first scam. The next one takes a different approach. Instead of adding a container, we now have two distinct, let's say, variants of types. We have nullables and non-nullables. And the implementation is more or less the same in all languages that I've seen. The types are non-nullable by default. Like, for example, if you say you want to create some kind of class or something, it's non-nullable. And if you wanted to actually store a null value, then you create a type which is actually nullable. And you cannot assign a nullable value to a non-nullable type. That's blocked by the compiler. And that's pretty much it. And here's a few examples. As you can see, the difference between a nullable and a non-nullable type is usually just a question mark in most languages. Then when you have the actual usage, there's a lot of actual compiler support behind it to make usage quite painless. There may be extra operators like the same question dot that we saw previously, or you may get expressions like the or else expression in SIG, which allows you to specify a default value if your nullable variable actually contains a null. And then sometimes the compiler goes the extra mile and does something fancy like converting the nullable type to non-nullable if you actually prove to it that this nullable variable doesn't actually contain a null. But we'll get to that in a second. So basically, there's nothing special about non-nullable types. They're still types. They just take one extra value, which is the null. Therefore, they can be used as any other expression. In any other expression, you can use them in your favorite if error is not nil thing. But ultimately, they are different types. So assigning a nullable value to a non-nullable type is not permitted. And like certain option implementations, there are a plethora of extra operators that make using them quite easy. And as I said before, support for nullable types doesn't come with just extra operators. Certain languages employ control flow analysis, enriching definitions to further ease the use of these types, like Kotlin and Dart. In there, for example, if a user at the time of usage proves to the compiler that the value is not nil, for example, with an if block or if they return early, then the value is promoted to a non-nullable one, and you can use it freely whenever an API wants to consume such a type. Go, unfortunately, is quite late to the party there. For all of those languages, the non-nullable type is the default, and that makes things pretty easy. Basically, when a language has this default, the ecosystem evolves naturally to consume these non-nullable types. With Go, that's really not a possibility because, well, we'd have to change the language completely. You can't just change the IPA, that's a breaking change. And again, the same story with operators. It's not like Go will suddenly start implementing those new operators. In fact, there have been proposals for those exact operators before, usually around error handling, and they have all been rejected. So we are going nowhere in that regard. And while it's true that we can have non-nullable types by default, we can have them as variants. It's not an ideal solution, certainly, but at least we can entertain the idea here. So let's say that now we have non-nullable type variants. They would just be like regular types, but they cannot be assigned a null value. And we can make the compiler throw an error if we assign one. But how would we use them? Like, we don't have any special operators. There's no way to actually pass them to a function that accepts a regular value because, well, as we said, the compiler will throw an error. That means that we'd have to implement certain things that other languages have. For example, we'd have to start using those control flow analysis to make sure that these types can be assignable to nullable ones if you prove to the compiler that they are in fact non-nil somehow. And this is just a slight example of what might look like. It's not very pretty, I'd say. Now it kind of looks like Perl if you squint enough. There's certainly lots of extra noise there, but it's, I'd say, a bit smaller than if you have like an option wrapper or anything like that. So, you know, it might be doable. And so we're left with a few considerations. We can't really change any of the existing APIs to accept non-nil types. That is a breaking change and would require a new version of the module that does this. And the compiler certainly needs to become a bit smarter. But as we've actually seen in the previous presentation, the compiler always gets new bells and whistles with its release, so that's not really that far-fetched, unlike adding operators. Then we arrive at everyone's favorite punching bag, the error handling. And while checking for an error is always a good practice, if we imagine a world where Go has non-nil types, it's not very useful in some cases. Consider the case where some function returns a pointer and an error. Checking for the error doesn't guarantee that the pointer is not null. In fact, the type system itself right now doesn't guarantee that, and yet for some reason, we always end up just checking for the error. We usually don't check for the actual pointer. That's why I sometimes actually return news for both the pointers, just to mess with people. So yeah, ideally, we have to check both. And that would be a net win in my book, but yeah, that's something completely different. Now, on the bright side, a couple of months ago, I noticed on Hacker News that the JDK people have recently dropped a draft JEP regarding a concept that's actually quite similar. These are the no restricted value class types. And basically, it's more or less the same thing. You mark a class as not nullable, and then whenever you attempt to cast from unnullable to non-nullable, the compiler prevents you from doing so unless you actually prove to it that, you know, the value is not null. The same, just like the other languages. So it might actually not be that crazy of an idea after all, if it works in Java. And just a reference slide for completeness. Yeah, that was my TED talk. Sorry for being so short, and thank you for listening.